All right, so hopefully you can all see this screen over here because we only have one. But anyway, my name is Elyes Graba. I'm a software engineer at Granular, work right next to Larry. So he just claimed that, whatever you want to come and present will probably be interesting to everyone who comes here to watch it. I guess we'll find out if that's true momentarily. I worked for my first year out of college at this business intelligence company where we were building a web app for querying databases easily, making visualizations out of the data, statistical analysis, and so on. And so being a web app, of course, I was writing a ton of JavaScript, which I had virtually no experience with coming out of college. Maybe I had to do some project in D3 once, but that was about it. So it's something that I largely learned on my own by Googling stuff and asking my coworkers, bothering them, and so on. And then after about a year of doing that, I was pretty competent in JavaScript, I felt like. I knew the language, or so I thought. And this trusted friend of mine, who's also a developer and very intelligent, suggested to me that I check out this book series by this guy named Kyle Simpson. So if the name is familiar to any of you, maybe go outside and smoke a cigarette during my talk so that, you don't ruin it. No, just kidding. But so I read his books and I found it really eye-opening because he discussed a lot of nitty-gritty details of JavaScript that I totally had no idea about, despite thinking that I was a competent practitioner. So when Larry asked me to talk, I went back and revisited some of the video lecture version of these books just to refresh myself and kind of build a presentation. And then I just paraphrased the knowledge that I'd gained and wrote some examples, made some slides out of it. So we'll see how this goes. Also, I want this to be a relatively interactive presentation. So I'll probably ask a couple questions at least, and I would love it if someone would answer. Unless you know the answer, then I'd prefer that you be wrong so I can be the hero against misinformation. But yeah, if nobody answers, then I'll probably just point at someone randomly, maybe Larry first. It's an easy choice, but any of you could be next. So let me start out with a question. Do we think that JavaScript is compiled or interpreted as a language? I feel like Larry knows the answer. All right. Okay, that's actually a great answer. So basically, it's definitely compiled. You can't sit here and say that JavaScript is a purely interpreted language. That wouldn't make much sense at all, given that we have variable hoisting, which is totally a terrible name for what actually happens. It seems to imply that your variables, when you declare them, are somehow magically brought to the top of your script by the JavaScript engine. That's not actually what happens at all. It's an artifact of the fact that JavaScript is a compiled language. But because variable hoisting is a thing, JavaScript definitely can't be an interpreted language, at least not purely interpreted. So this super simple snippet of JavaScript right here, we have a stupid function that just adds its two arguments. If we log the result of calling that function, then you'll see when we run it, we just get 5. It's not a problem at all for the Node JavaScript engine to run this, even though we're accessing the function before it was declared. So if we contrast that with a purely interpreted language like Python, we have the exact same example here. It's a major failure, crash, server goes down, everything is terrible. The interpreter is going line by line. It hasn't scanned anything beforehand. It has no knowledge of the fact that func exists when we try to print the result of calling it on that first line there. So the interpreter fails, func is not in scope, so on. Now, you could also make some arguments as to why JavaScript is interpreted, but I would say that compiled, and specifically the just-in-time compilation model, is probably the best way to think about it, because you could also make some arguments as to why Java is an interpreted language, but really those arguments don't hold much water and nobody would ever sit here and say that Java is interpreted. But technically, the Java compiler doesn't produce machine code, it produces Java bytecode that is then interpreted by the JVM, right? So if something similar is happening with JavaScript, which it is, depending on the implementation, but in most major implementations that is what's happening, then clearly we should just call it compiled, right? Since everybody else is already calling Java compiled, and that's not really a contentious point. And furthermore, I'd say that it's definitely not transpiled. It's not an argument of it being compiled versus transpiled, because a transpiler is something that takes a script in a given language and transforms it into maybe a script in another language altogether, or an older version of that script, as we're all probably familiar with, like having to transpile our JavaScript to ES3 or whatever, so it's compatible with old browsers. But that's not necessarily what's happening either, because the JavaScript compiler is stripping out certain tokens, certain declarations that are necessary for syntactically valid JavaScript. So in other words, if you take the output of the JavaScript compiler and run it back through the JavaScript compiler again, you're going to get syntax errors immediately because the output of that compilation process is not valid JavaScript. Anyway, that's a pretty academic point that is really probably irrelevant to everything that all of you do day to day. So it's not going to get any better from here. That's what this entire talk is about. But just to give you a quick overview of what the compilation process looks like, which maybe if you've taken like a really low-level computer science course or something like that back when you're in college, or you're just a huge nerd who like studies this stuff because it's fun, then you might already know this, but just as a super quick refresher, there's basically 3 stages to compilation, 3 major stages that we should think about conceptually. So the first one is tokenizing or lexing, and that's basically taking a stream of characters that comprise a script of a program and breaking them up into symbols that have atomic meaning, like var in JavaScript. That is like a symbol that means one thing. We're declaring a variable here, and it should be taken by itself. The only difference between tokenizing and lexing is whether you take a stateful approach to this process. I think lexing is the one that's stateful. Doesn't really matter. The second step is parsing, which is basically taking those symbols from the tokenizing and lexing process and building an abstract syntax tree out of them. And lastly, we have code generation, which is the step where we take that abstract syntax tree and transform it into something that can actually run on bare metal, right? Like a processor doesn't know what to do with an abstract syntax tree. It doesn't know what to do with JavaScript. It doesn't know what to do with the stream of symbols that comes out of tokenization. It only knows what to do with machine instructions. So ultimately, we have to generate those machine instructions, right? So just as a kind of visual explanation of this, we have like a really simple snippet of JavaScript here. We're just declaring a variable and assigning it to some number. So the tokenization or lexing process would produce something like this, a stream or an array or a buffer, or however you want to think about it, of atomic symbols like, hey, we're declaring a variable, that's its name, we're assigning it, so on. The parsing stage would take that, turn it into an abstract syntax tree. This is something I just pulled out of thin air, but it's roughly what an abstract syntax tree might look like. And lastly, we get this shit that hopefully we'll never have to look at in our careers, right? Because like we left that behind in our computer organization class, and writing assembly is just god awful. So to get into some more specific JavaScript stuff, let's talk about scope real quick. So scope is basically, it's a really simple concept. It's nothing more than a set of identifiers, which people might commonly call a namespace. So like we have sort of a region, like almost like a spatial region of our program. These are the identifiers that have been declared. Like maybe we have 3 variables there, and that one is a reference to a function that does something cool. And it also has a reference to its parent scope. In the case of JavaScript, I should add, which uses a lexical scope model. So we probably all know about the global scope in JavaScript if we've written any of it, right? Like we know that there's a window object if you're operating in a browser. The window object exists in the global scope. It can be accessed pretty much anywhere from within your script. But like what other things create their own scopes in JavaScript? So if we're going to talk about the original version of the language that, first came out when JavaScript was invented, the only thing that created scope was functions. You had the global scope and you had the scope created by a function. Now we kind of have scope that's created by blocks, but it's a little bit of a mystery because that wasn't really a thing in the early versions of JavaScript, and now it's only a thing sort of. So I would add the caveat that block scope only exists with the proper usage of a variable, of one of the 3 variable declarations that you have in JavaScript. So, all right, here's another quiz question. I have this extremely nested snippet of JavaScript. We've got 3 functions. Each one calls the function that's defined within it. And here we have, inside the innermost one, we're logging 1, and then we may or may not be logging something here, and then we log 3. So ideally, if this were to run, we'd get 1, 2, 3, right? But what actually happens? All right, I'm going to point at you, Larry, as promised. That's pretty wrong, but I appreciate the confidence. So what's actually going to happen in this example is that we're inside of 3. We get to this line here, and the JavaScript engine, which is executing the code, is going to ask its helper, which is the scope, do you have a guy named A? And right now we're looking at the scope of 3, right? Because functions create scope. There was definitely no variable named A that was declared in 3. So then we're going to ask the parent scope. Let me not get ahead of myself here. We're going to ask the parent scope, which is 2. There's no declaration in 2. We're going to go to 1. There's no declaration in 1. So then the last scope that we can go up to is the global scope, right? So what happens when we get to the global scope? Well, as you can see, that's line 1 up there. There's nothing above it. A was never declared in the global scope either. So the JavaScript engine is just going to happily, oh yeah, I was actually, this is for you, Larry. You're wrong. The global scope is actually going to happily create the variable A for us at runtime. Like, this is not an error. It's going to create A in the global scope, and then it's going to go back to executing here on line 5. It's going to assign 2 to A, and it's going to keep chugging along. So if we actually run this example, we'll see that we print 1, 2, 3, and down here, outside of, outside of any of the functions, we print A again, and it happily prints 2 because A exists in the global scope. So this is actually terrible because it allows people to write completely shit code, and the JavaScript engine will happily create these variables during runtime, which is extremely slow, and it allows developers to write like extremely confusing code because A was never declared anywhere in the snippet. You can imagine that if this is a much longer, more complex real-life example, I mean, you could spend a day going down that rabbit hole of trying to figure out what's going on. So you always put use strict at the top of your scripts because there's basically 2 different modes that JavaScript can execute in. It can execute in strict mode, or it can execute in non-strict mode. This is another like pretty academic point that probably doesn't matter because if you use any bundling tool like Webpack, Browserify, or so on, they're always going to inject this at the top of your scripts for you. But nonetheless, if you ever were to write like a one-off script where you weren't using a bundling tool, it would be pretty important to remember to put this at the top. It doesn't only save you from automatic global creation, it saves you from a lot of other terrible pitfalls from the early days of JavaScript as well. So, to get back to scope, in JavaScript, scope is lexical. And if you remember what I said about compilation, lexing is the first phase of compilation, right? Go ahead. Yeah. Well, yeah, I mean, there's 2 layers to it, right? Like, there's the performance aspect. It's really slow. It completely interrupts the JavaScript runtime to create a variable in the global scope. But also, it's stylistically really bad practice because it's just extremely confusing. But like in Python, again, that's a purely interpreted language, right? So, and it has a completely different model of like variables. It doesn't even have variables per se. It's names if you're really going to be like strict about your terminology, I guess, in Python. But with JavaScript, being that it's compiled and then the result of the compilation is interpreted, declarations are important because they are a cue to the compiler to put that variable in the scope in which it's found. So, like, in that example, A probably should have been in the scope of that innermost function, but it ends up in the global scope because that's just what happens when the scope resolution process fails.
So, sorry to sidetrack again, but if in the example, if you did like let A equals 2 or var A, would that change how the output would be?
It wouldn't change the output in terms of like what's actually printed to the console, but it would definitely change. Well, actually, that's wrong. Sorry. If you were to change this to a let declaration here on line 5, then this would be a reference error because then A would only exist in the scope of 3. So anyway, scope is lexical, which to go back to like the steps of compilation, lexing is the first step, right? So lexical scope means that the scope is defined at lexing time. Like literally when the compiler is going through the code and generating these arrays of symbols, at that point it already knows what the different scopes are and what variables are attached to them. Yeah, keep forgetting to like click forward in my slides. Okay, here we go. So there are two language features that can actually cheat this though. So with is deprecated, and I'll talk about that more in a second, but eval is a built-in JavaScript function that takes an arbitrary string of JavaScript code and just starts running it. So like, it's a pretty unsafe operation, but sometimes you need to do it for if you want to write really dynamic programs that generate code and then run them. The problem with eval is that it doesn't create a scope for the code that it executes to actually run in. It just runs that code inside the scope that the eval statement was found in. So basically, if you have an eval inside your function and that eval declares variables, it's going to start adding those variables to the scope of your function, which, you know, is A, kind of slow, but B, it's a bit of a bad practice, unless you use ustrict. That actually forces the JavaScript engine to create a new scope for any code that's evaluated within a call to eval. So with is this shorthand that used to be in JavaScript, I guess still is really. And it basically allows you to take an object and sort of create a block where that object becomes the scope of that block, which sounds a little bit contradictory to what I was saying earlier about there not being block scope in JavaScript, but honestly, like, I'm not even going to bother to try and explain myself because with just doesn't even make any sense. But basically, it gets me into this nice situation where I don't have to say a.name equals whatever. Any variable assignments within the block happen to properties on the object. Like basically the properties on the object become the scope of this block. But because of that and because of the way that JavaScript uses lexical scope, if I try to assign something to a variable that doesn't exist on the object, it's going to query the current scope, which is that object. It's not going to find it there. It's going to query it in the next scope, and it'll maybe find it there, in which case it'll overwrite whatever the value was, or it'll go all the way to the global scope and end up creating ID, in this case, in the global scope. This will actually print down here, and like I think we can all agree that that's actually truly terrible. You're trying to assign properties on an object, and you end up creating a variable in the global scope. So if you use ustrict, JavaScript will throw a syntax error when it encounters a with statement. Okay, so if we look at this snippet real quick, how many variables are there? How many identifiers are there in the global scope? Okay, that's right. There's two identifiers in the global scope, right? There's identity and then there's Baz. How many identifiers are there within the scope of Baz? Okay, that's exactly right. There's three. There are B and C, which are pretty plainly declared right here inside of Baz, so they clearly belong to the scope of it. But whenever a function has an argument, like a formal parameter as they're called, as opposed to like using an arguments array that you get in JavaScript, which you probably shouldn't use. Whenever you get a formal parameter to a function, that becomes part of the function scope as well. So there's three identifiers inside of Baz. Okay, so to get back to JavaScript and its functional scope model, if we declare this function and we have an if block inside of it where we declare a variable and then we log the value of that variable, like I think we can all agree on this, right? We're going to get 5 if we log it here. We're also going to get 5 if we log it down here, which is maybe a little bit more contentious because a lot of languages wouldn't allow you to access a variable outside of like an if block in which that variable is defined. That would be block scope. This is kind of gross. I mean, it can lead to some bad code, you know, when you're declaring variables inside of an if block and then someone's using them further down outside of that if block, maybe where you didn't intend for that variable to be used. Or maybe somebody like tries to redeclare the variable down here thinking it'll be different and it's actually not. But anyway, probably the worst part is this. If we log it up here before it's defined, or declared rather, we'll actually get undefined. And the reason for that is because the variable declaration, this var result, is hoisted, which again is not a thing. Nothing is like moving your JavaScript code around physically. But what it really means is that the declaration of the variable is a compile time operation, and the assignment of the variable is a runtime operation. So when we declare variables with var, the compiler also magically initializes them to undefined for us. So if we then print them before they're assigned at runtime, we get undefined. I mean, it's okay, I guess, but it's not really like ideal behavior. This doesn't really lend itself very well to writing good code that's like rock solid that other developers can come in a year later and understand. Like if you're allowed to do stuff like this, then you're kind of setting yourself up for some spaghetti. If the if statement wasn't true, then this would print undefined, and this would print undefined as well. Because the compiler is going to go through, the compiler is not going to check the value of this Boolean and like decide whether to evaluate that block. It's just going to see this declaration, it's going to attach it to the scope of something, and initialize it to undefined. And then when you actually run, you're just going to get undefined in both of these places. And of course, this won't happen.
I mean, there. I don't know if it's a result on the value. If you didn't have this, you would have to find var result. Not a great argument, but
It saves you a line of code at the expense of like making really confusing code. I don't know. I mean, I see your point, but like it should be block scope, right? Like if you want to have result take on two different values depending on some conditional, then you should declare it. And most linters will force you to declare it inside the function itself rather than inside of a block. But this is even worse. So if you declare a loop variable with var like this, same thing will happen. We can access I before we actually get to the line of code where it's declared because it's already been added to the scope in the compile phase. And we can access it down here as well. After this loop has happened, I is still sticking around in the scope of other thing, and another developer could totally take I and like start doing their own computation with it, which is, I mean, I think everyone can agree that that's pretty disgusting. Like when you use a variable inside of a loop, it's not meant to then be used elsewhere unless you're writing like one of those crazy competition code things where you have 5 lines to do the most ridiculous thing possible. So if we had block scope in JavaScript, it would look like this. We would declare a variable inside of our if block, and if we try to use it inside of our if block, everything goes smoothly. If we try to use it anywhere else, we get reference errors, right? And we do have block scope in JavaScript. We got it eventually. So is it ES4 or ES5 that they added let and const? I don't know. But in any case, eventually they did add these 2 other ways of declaring variables called let and const. They're roughly the same, except for the fact that when you declare something with const, it has to be assigned immediately, and it can't be reassigned later on. Otherwise, as far as scoping is concerned, they behave basically the same way, in that if I declare a variable inside of a block, I can use it inside of that block, but if I try to use it outside, not going to work. I know that this is like valid and a lot of people like to use const inside of their loops, but like personally I hate it because I just hate seeing const in the loop variable. But the reason that that works is when you use const with a loop or let, JavaScript is smart enough to rebind the variable each iteration of the loop, and it's also smart enough to, instead of rebinding it to what you assigned here, it rebinds it to what the previous value was on the last iteration of the loop. So even though it's a const, it's not really a const. That doesn't make sense to me, but people seem to like it. But anyway, it prevents us from being able to access that loop variable anywhere outside of the loop, which is good news to me, because if I wrote code and then some developer like took the loop variable and did something else with it, and I came back and saw that, I'd be really upset. You know, I don't think so. I'm not sure why people, I think people are like addicted to using const. They're like, you should always use const anywhere that the compiler will accept it because const is, it prevents bugs. But like, I don't really buy that, especially in a loop. So block scope, if you were to ask what is a block, like is it an if statement? Does that create block scope? Does a for loop create block scope? Literally just a pair of curly braces will create a block scope in JavaScript. So you don't even have to have a loop or a if block or anything like that associated with it. So if maybe I want to do some like partial computation inside of a block and then not have that variable accessible anywhere else, I can just put curly braces and the JavaScript runtime will enforce this.
Slow on the uptake here, but like if you ran a loop where you change your variable
Yes. Yes, that's true. And that may actually be a good argument as to why one should use const. So, thank you. All right, you should use const in your loops. Never mind. I was wrong on that one. So actually, though, we did have block scope in JavaScript before they introduced the let and const keywords. And weirdly enough, it was in ES3, and it was catch blocks. For whatever reason, they decided like the one thing in ES3 that was going to have proper block scope was catch blocks. If you tried to access the error variable that is passed into a catch block, outside of the catch block, you get a reference error, same as if you were to try to access any variables that were declared within the catch block. It's kind of useful because like if you have multiple catch blocks, you can name the error variable the same thing each time. I mean, I don't know how useful that actually is, but it's just baffling to me that that's like the one thing they decided they would implement block scope for. But I mean, JavaScript in general is a bit baffling, so that's what makes it fun. Doesn't make sense. All right, so now that we've talked about scope a bit, I just threw together like a quick visualization of what scope actually looks like. So we have a global scope here. Obviously, it's highlighted in magenta. We have a scope of the function foo. We have a nested function with its own scope in green, and then we have a block here that has its scope in blue. So if I had used var there to declare partial, then this diagram would be a lot uglier because then partial would belong to the scope of nest egg, right? So then I'd have to like extend my green box. It wouldn't be a box anymore. I'd have to like get partial in it. And then I guess blue wouldn't even exist because there would be nothing in the scope of blue. But anyway, if we actually look at what this scope sort of like builds to as a data structure, we get this, right? We have our innermost scope that has an identifier in it, reference to its parent, and so on. And it's of note that like these references only go one way, right? A scope can only query its parent. If you're trying to access a variable, you'll never get in the situation where a scope is like, let me ask my child scope if it has that variable. That would be wonky. But anyway, so one serious advantage of let and const over var that I think is pretty cool is that like if you were to do something like this where you read something from a file and it's like 10 petabytes, which is just ridiculous, and you want to process that data, and then you want to continue on with your life, that's some really big thing that's sticking around in memory. It has to stay there for the duration that your program is running because the JavaScript engine has no way of knowing ahead of time whether that variable, some really big thing, is going to be used anywhere else. So even though we put it inside curly braces, it's declared with var. So in this case, it belongs to the global scope, and you just can't know ahead of time is something else in the global scope or any nested scope, because they can all access the global scope, right? Going to try and access that and do something with it. So you have 10 petabytes of junk hanging around in your memory. Whereas if you simply just declared this with let or const, then as soon as that block is done, as soon as process is done running, assuming it's a synchronous function, and we continue on with life, JavaScript engine is free to garbage collect some really big thing because since you declared it with let inside of a block, it knows for sure that it can't possibly be used anywhere else because that would be a reference error. Of note, though, with let and const is this thing that people call the temporal dead zone, which some people misinterpret as let and const not being hoisted, but really let and const are also hoisted. The declarations that you make with let and const are interpreted by the compiler. They are added to the scope at compile time, but the problem is that the compiler does not magically initialize them to undefined for you. It does magically initialize things declared with var to undefined. So in this first example, where I'm trying to add some number that's passed in as an argument to a different number that's stored in the global scope, I get not a number, which is pretty much what I expect, because the variable exists, but it's been initialized as undefined by the compiler. We haven't gotten to the line where it's given an actual value yet, so undefined plus 2 is not a number. But if we do that same example with let or const, we actually get a reference error inside of the add function. And it's kind of a different reference error, like not concretely speaking, but it's kind of a different reference error philosophically speaking than what we would get if let and const didn't exist at all. Because in both of these cases with let and const, A was put into the global scope at compile time, but scope is like a mapping of a variable name to like a reference to where the value of that variable exists. So with var, the compiler goes ahead and says, oh, this variable maps to undefined. With let and const, the key is just there in scope. There's no associated value. So we get a reference error. I mean, this is like truly useless, because I mean, what's the difference for your script, right? Your users don't care. But it's fun JavaScript trivia that you can maybe like, I don't know, tell somebody at a bar. So, all right, let me ask what's the difference between these two scripts?
First one just says not. Second one,
Yeah, absolutely. And I think that's why people like have pretty much abandoned var. I mean, there's not like a whole lot of good arguments to why you should keep it. Like some super nerds might be like, well, people just don't use var because they don't understand it. But like, I don't really buy that. Like this first case is not even really an error, right? It's like it happily tried to add undefined to 2 and just happens that in JavaScript that means not a number. But yeah, like you said, like your program will just keep running and that error will manifest somewhere else and it'll be a million times harder to track down. So I'm definitely not trying to advocate that anyone use var willy-nilly. I'm just trying to give like a historical account, more so, of the old days when things were horrible. But, okay, to get back to this slide, I'll go ahead and tell you there's basically no difference semantically between these two because of what people call variable hoisting. People imagine that like this left side snippet gets compiled to this right side snippet, the var declaration gets hoisted to the top of the script. That's really not what happens. The compiler interprets the declaration, and then at runtime, it's almost like the declaration's not even there. We just see the assignment, and then we log the value. But you could kind of think of them both as getting compiled to something like this in a very abstract sense. The compiler does the var baz part, it puts that in scope, it sets its value to undefined, and then the runtime actually assigns the value to baz and does the logging. Okay, so we've talked a lot about let, const, and var, but like how do functions work? So in this first example in the top left, we've got a function declaration, right? So a function declaration is basically any statement where the first thing in the statement is the word function. As we saw like way back at the beginning, this will run just fine. The compiler interprets the declaration of the function, and then at runtime, we're able to call it and see its result. But what happens here? So like, we're gonna get an error on this line, but what kind of error are we gonna get? Eric. So, I mean, yeah, it's going to be a type error because the compiler goes through and it initializes it reads the declaration of func, which is a variable, and it magically initializes it to undefined for us. But this right-hand side where we're actually not declaring a function, but this is a function expression because the first thing in the line is not the word function, this happens at runtime. So when we get here at runtime, func has been magically initialized to undefined by the compiler. Well, undefined is not a function, so we get a type error. Kind of weird. But basically, function expressions are useful because they don't actually add the name of the function, which in this case is underscore func. They don't actually add the name of the function to scope anywhere except inside the function itself. So like the reason that underscore func exists as a name inside of the function itself is so that we can do recursion, right? Like we need something that we can refer to this function as if we want to call it from within itself. It's kind of an important distinction between the two because like we've probably all seen something like this a bajillion times. But the problem with it is that we have a function declaration and it's polluting the global scope with the name on click, which you're probably going to encounter like 600,000 times in your code base. So any other declaration of on click could overwrite this. There would be a name collision, right? But if we do this instead, where we're passing the function inline as an argument, then it becomes a function expression where the name on click isn't added to scope anywhere except inside of the function itself. And so there's like two advantages to this as opposed to passing an anonymous function that doesn't have a name. The first is that if we have an error inside of the function, our stack trace will actually have a name to print versus just like there's an error in some anonymous function somewhere. And second is that we can do recursion without using arguments.callee, which is like a pretty arcane feature in JavaScript that just doesn't lend itself to readable or good code. And then lastly, there's this thing known as the immediately invoked function expression, where we define a function, but we wrap it in parentheses, and like literally even the fact that this line starts with an open parenthesis is enough to make this a function expression rather than a function declaration. So it doesn't go into global scope or any enclosing scope. And then we immediately call the function with or without an argument. In this case, we want to give it an argument, so we do. And that can be useful for certain things that we use every day without maybe realizing. But before I get there, last thing I wanted to talk about is closures, which is basically just the fact that any function or scope can access variables that are defined inside the scope above it. So like in this case, inner can easily access and log the variable name even though it's defined inside the scope of the function outer. So in this case, we say that inner has a closure over the variable name or over the scope of outer. But this isn't actually like a super good example of a closure because it doesn't involve anything that can't be explained by the lexical scope model of JavaScript, right? When inner tries to find the name, or excuse me, the variable name, it just checks its own scope, it doesn't find it, it goes up one scope and it does. That's just lexical scope. But where closure like really comes into play is if we have an example like this, which is slightly different. Instead of immediately invoking the inner function inside of the outer one, we actually return it. So we capture that function here in the variable f, and then we call it. So now f is executing in the global scope, so it can't just go one scope up and find the variable name. But functions in JavaScript magically maintain this like closure reference to the lexical scope that they were defined in. So even though that inner, which is now named f down here, even though that's executing in a completely different scope than it was defined in, and that scope doesn't have a reference to the scope where name is, this will run just fine and it'll be able to resolve name. So I mean, we've all used this a million times, but this is just kind of like a formalization of that concept. Okay, so real quick, what gets printed here? Jake?
1,000 times. Sorry, 1 after 1,000.
Okay, we're actually going to get 10 times because this loop variable it doesn't have any like scope association because it's declared with var. And 1,000 milliseconds after this loop is run, the loop is like definitely done. 1 second. And I is just permanently set to 10 because that was like the termination condition of the loop. But if we change it to this, where we have an immediately invoked function, notice like those parentheses where we're invoking it down at the bottom there, and we reassign I to a different variable j that's declared with var, the j variable now exists in the scope of wrapper, so that when we print it, we'll actually get 1, 2, 3, 9. So, which is what we want, right? Which is what we would expect in most cases. So this is like a good example of how you can use the fact that functions create scope to get the intended behavior. In fact, if you define a function within a for loop, most linters will tell you not to do that because they're like, you probably don't know what you're doing and you're going to screw something up. But we actually don't need to do any of that immediately invoked function expression wizardry, because if we just use the let keyword instead, not only will the variable I be scoped to the for loop itself, but it will also be rebound and redeclared every time the for loop, sorry, not redeclared, rebound every time the for loop executes, so that when this happens, the function can get a proper closure over the variable I. The next time the loop goes around and sets I to 2, that's a different I because it's rebinding the name.
Something I was thinking of var versus let. Are there performance considerations? I know we don't control out, but we have a large loop for example, with var versus
var would actually be like faster because it's not rebinding the variable each time, but I mean, I don't know. That's kind of my high level analysis, like when I think about the ways that the two different approaches work, but like it's also possible that the compiler like does some optimization that really they're the same and you just get all the benefit from using let. But even if there is a performance difference, like it's certainly so small that unless you're doing algorithmic trading or something, which why would you do that in JavaScript? Unless you're like a super JavaScript hipster. Okay, so wrapping up here, globals are bad. We all know that globals are bad because they pollute the namespace, the global namespace, with lots of different names. These names might collide, they might overwrite each other, they might cause confusion. But if we create a function, then that function gets its own scope, and all of a sudden those variables that may have previously been globals exist inside the scope of the function instead. So this is basically how every bundling tool ever works. Like Webpack, if you've ever like had the misfortune of trying to set a breakpoint in your front-end JavaScript and like you end up in some Webpackified code, you know, your source maps weren't set up correctly or whatever, you'll see that pretty much everything is wrapped in a function that's named like _Webpack, some indecipherable hash. But the reason that is because like all these bundling tools, they use the immediately invoked function expression pattern to expose APIs. All of the API objects, all the API functions, methods, they're defined within this wrapper function so that they only pollute the scope of that wrapper function. And then you only have to have one name in the global scope, which is basically a reference to the result of executing that function. That's a very like quick and dirty way to say that, but I believe I'm done here. So I'll just go ahead and shut up since the entire talk was useless anyway. Back with the quiz slide. No. Oh my God, I have so many slides. There we go. This one? Okay. I see. Well, okay. In this example, at least, there are two. But what was the question?
When Webpack runs, it tries to make sure there's one.
Well, it's not really one per se. It's more like, I mean, it's pretty complicated because Webpack can like arbitrarily wrap different things in functions. But basically, like, if you like have ES6 modules, if you take that as an example, where like one file is kind of its own namespace, like native, I shouldn't even say native, older versions of JavaScript don't support that. Like anything that you write at the top level of a file becomes part of the global scope, but Webpack or other tools like that will smartly wrap that entire file inside of a function, so all those declarations become part of the function scope instead, and then you only have to have one global variable which then references that function rather than however many were in the file. Yeah, I have talked more than enough.